All right, in this lesson, we are going to be still dealing with independent events. That's where the first one does not impact the next one. But what we're going to do today is we're going to have a little more visual way of looking at it. Last time we just multiplied some numbers together. This time we're going to visualize it with something called a tree diagram, and hopefully by using that, you'll kind of see why those probabilities occur. And let's unlock the screen. It went to sleep. Okay, so we're going to again go back to that flipping a coin. So for that coin flip example, we're going to show how a tree diagram can work for this. So suppose you flip a coin once. What's the probability that you get a heads? So you are given a coin and you could either flip it and you could either get a heads or a tails. So the probability of getting a heads is 1 out of 2, so I'm going to just call it 1/2, 50%. And that's too simple. So what we're going to do now is we're going to flip a coin twice. And now I want to know, what's the probability of getting both heads? Well, you could have flipped that coin and you could have gotten a heads on that first throw. And now on the second throw, you could either get a heads or a tails. And similarly, you could have gotten a tails on the first throw, and then you're going to throw it again, and you could either get a heads or a tails. So what this leaves you with are all the 4 different possibilities of what you could get. You could go here and here, and you'd get heads, heads. You could go here, then here. That's a heads, then a tails. You could go this pathway, where you go tails, then heads. Or you could go this pathway, where you get both tails. So that's what each of these endpoints represents, is a different pathway that you could take. And of those, the probability of getting both heads are 1 out of 4 different possibilities. So it's 1 out of 4, which is 0.25, which is 25%. And we got that same answer last time by just doing 1/2 times 1/2 is 1/4. So this is kind of what a tree diagram does, is it helps you visualize all of the possibilities. You could have gotten both heads, you could have gotten both tails, or you could have gotten one of each. So if you're asked for the probability of one of each, you could take these probabilities and add them together. So now let's go down here, and we're going to add a little more complicated numbers to it. So coins are easy because it's just 50-50, but not everything in life is going to be 50-50. So we have different numbers for probabilities. So we've got a certain student. They have a hard time waking up in the morning. I feel that. And they often show up late to school. I don't feel that. Should show up on time to school. From their attendance records, it is shown that this student shows up on time 68% of the time. The other times, they show up late. So let's remember the complement idea that we talked about last time. If they show up on time 68% of the time, that means they're going to be late all the other times. And that's going to be 32%. So 32% they're late. We could get that by taking 100%, subtract this 68%, and it gives you 32%. So here's Monday. This is going to be the first split, is Monday. They could either be on time or they could be late. So they are on time 68% of the time. I'm going to call that 0.68. Or on Monday, they could be late, and that's a 32% chance of happening. So this first split here, that was on Monday. So now let's pretend that they were on time on Monday. Super, that's great. Now they're going to get to Tuesday. Here's the next split. This split is for Tuesday. So now Tuesday comes. What's the chance that they're going to be on time Tuesday? Well, it's still the same chance. It's still 68%. And the chance that they show up late on Tuesday is 32%. And similarly, they could have showed up late on Monday. Shame on them. And if they show up late on Monday, they still could be on time on Tuesday, and that would have a 68% chance. and they could be late on Tuesday. That's a 32% chance. One kind of key idea about these tree diagrams is every time they split up, it should add up to 100%, or it should add up to 1. And you see that this happens in this case. So now what I'm going to do is, this is where the multiplication rule of probability comes in. If I want to find the probability that they're on time on Monday and they're on time on Tuesday, we can just take that pathway and multiply them together. So what I'm going to do is I'm going to go to a calculator and take 0.68 times 0.68, and it gives us 0.4624. So there's a 46% chance that they're on time both days. And I'm going to do this for each pathway. It makes answering the rest of the questions much easier when you have all the probabilities calculated. So if I want to find this next one, they're on time on Monday, but then they're late on Tuesday, we would take 0.68 times 0.32. 0.68 times 0.32 gives us 0.2176. Let's use a different color here. For this next one, they could be late on Monday, but then they show up, they learn their lesson, they're on time on Tuesday, so we take 0.32 times 0.68, multiply those together, and we again get 0.2176. I'm going to find some new colors over here. And we could be late on Monday and then late on Tuesday. So to do that, we're going to take that 0.32 times 0.32, and that gives us 0.1024. So that's the probability that they were late on both of the days. So this shows all of the different possibilities along with the probabilities of each one. Now that we have those, let's answer all the questions. What's the probability that the student will show up on time both Monday and Tuesday? Well, they have to be on time Monday and they have to be on time on Tuesday. That is this one right there. So 0.4624, which is 46.24%. About half the time, they're going to be on time both Monday and Tuesday. What's the probability that this student shows up late both Monday and Tuesday? So that means Monday they would have to be late and Tuesday they'd have to be late. That would be this scenario right here. So 0.1024. So we're going to put 0.1024, which is equal to 10.24%. Hopefully you see why it's nice to have all these probabilities here. Now we just have to pluck the answers and write them down. What's the probability that the student will show up on time on Monday, but then late on Tuesday? So in this case, they have to show up on time on Monday, but then they're late on Tuesday. And that would be 0.2176. And that's just 21.76%. And lastly, what is the probability that the student will show up late on Monday, but I'm assuming that whoever made this meant to say on time on Tuesday. We already found the probability of being late both days. So what's the probability that they are late on Monday, but on time on Tuesday? So they're late on Monday, but on time on Tuesday. That would be this one, which is again 0.2176, which is 21.76%. Now later on you might run into one type of question, and I want to point this one out here before, just so you don't get confused when you see it. I want to know, what's the probability that they are on time exactly once? So I want to know, what's the probability they're on time exactly one time? So let's just take a look and understand what each of these means. In this spot here, they were on time both days, Monday and Tuesday. Nice job. Under this scenario here, they were on time Monday, but then late on Tuesday. So here they were on time exactly once, one of the 2 days. If I go down here, they were late on Monday, but on time Tuesday. So yes, again, they were on time exactly one of the days. And on the last one, they were late, then they were late, so they were on time 0 days. That doesn't count. So if I'm looking for the probability that they're on time exactly once, it's these two scenarios. And what I have to do with those two is add them together. So if I want the probability they're on time exactly once, it would be 0.2176 plus 0.2176. Either of them could happen for them to be on time exactly once. And if you add those together, you get 0.4352 maybe, which is about 43.52%. So you might run into this type of question later on when we're talking about Stephen Curry shooting free throws. It asks, what's the probability that he makes exactly one of his free throws? So keep that in mind when you get to that question. But other than that, that should be it for these notes. You've got a couple to do on your own. Submit them on Schoology when you're done, and then hopefully you're ready for the quiz this week.